All right, today we're going to work with 5.3 properties of addition and multiplication. Our standard is 6th grade evaluating expressions A. Our objective is that we're going to be able to write algebraic expressions and solve problems involving algebraic expressions. Our mathematical literacy, we have equivalent expressions, commutative property of addition and multiplication, the associative property of addition and multiplication. Okay, so for 5.3, properties of addition and multiplication, our success criteria is that we're going to be able to explain the meaning of equivalent expressions and also use properties of both addition and multiplication to generate equivalent expressions. Okay, we'll kick this off with the mathematical literacy. By that, I mean our math vocabulary. Now, the first thing I want to talk to you guys about is equivalent expressions. Now, in math, an expression is a mathematical phrase that contains numbers, variables, and operators. By operators, I'm talking about addition, subtraction, multiplication, and division. These are operators. Variables, it could be any letter from A through Z, and they represent an unknown value. And so let's go ahead and talk to you guys about the identity property of addition. Now remember that properties, they're like a set of math rules that are always true, and they often help us solve math equations. Now the identity property of addition is basically like, it looks like this. If we have a plus 0, that's going to equal a. We're using the variable a here, plus 0, it equals a. So this says that if you add 0 to any number, the number stays the same. Okay. We also have the identity property, again, a set of rules, set of math rules of multiplication. So this is like a times 1 equals a. If you multiply any number by 1, the number stays the same. Let's do an example real quick. Let's say that for a, let's say a equals 5. So if we substitute a or 5 for a, 5 plus 0 will equal 5. And that's the identity property of addition. Let's say over here that, again, a equals 5. So if we have substitute 5 for a, 5 times 1 equals 5. So remember, be careful that whenever you multiply anything times 0, then everything will be 0. Okay, we call that the identity property of 0. Now let me talk to you guys about the commutative property of addition. So with the commutative property of addition, it looks like this. So we have a plus b, that's going to be equivalent to b plus a. So this says that when you add 2 or more numbers, you can add them in any order that you want and the answer will be the same. Let's say a equals 3 and b equals 11. So when you substitute 3 for a and 11 for b, you're going to have the same value. So 14 is equivalent to 14. So it checks. Again, these are equivalent expressions. Okay. Now for the associative property of addition, it kind of looks like this. So if we have a plus b and then have that plus c, that's going to be equivalent to a plus b plus c. So notice the parentheses. I had the parentheses around the a and b first, and now I have it around b plus c on the other side of the equation sign. Now, this basically says that when you add 3 different numbers, you can change the order that you add them by moving the parentheses. No matter what, though, your answer is going to be still be the same. So let's say a equals 2, b equals 3, and c equals 4. So if you substitute these, a equals 2, b equals 3, and c equals 4, that's going to still be equivalent to let's see here, 2, 3, 4. When you do the associative property of addition, now parentheses usually tell you to multiply, but we're going to do and solve what's inside the parentheses first according to the order of operations. So 2 plus 3 is going to be 5, plus 4 is going to be 9. That's going to be equivalent to 3 plus 4 is going to be 7, plus 2 is going to be 9. So again, 9 is equivalent to 9. These are equivalent expressions. All right, for the commutative property of multiplication, it looks like this, where we have like A times B. That's going to be equivalent to B times A. Again, this basically says that when we multiply two or more numbers, you can multiply them in any order that you want, no matter what the product is going to be the same. So let's say that if we have A equals -5 and B equals +4, and if we substitute these, -5 times 4, that's going to be equivalent to 4 times -5. So anytime you have a negative times a positive, you're going to have a negative. Okay, so 5 times 4 is 20. That's going to be equivalent to -20. There you go. It checks. Again, these are equivalent expressions. All right, I do got to warn you guys though. Don't forget that the commutative properties for both addition and multiplication only work for addition and multiplication. The commutative property does not work with subtraction, and it does not work with division. Next, we have the associative property of multiplication. So it's going to look like this, where you have A times B times C. That's going to be equivalent to A times B times C. Again, this says that when you multiply three different numbers, you can change the order in which you multiply them by moving the parentheses, and the answer or the product is still going to be the same. So for an example, if we have A equals 2 and B equals 3, C equals 4, and then when we substitute, so 2 for A, 3 for B, and 4 for C. Okay, oops. Now, if we multiply 2 times 3, according to Gemma, do the parentheses first, that's going to be 6, times 4 is going to be 6, 12, 18, 24. Okay, same thing, 3 times 4 is 4, 8, 12, times 2 is going to be 24, and 24 is equivalent to 24. So again, the associative property of multiplication says that when you multiply three different numbers, you can change the order that you multiply them in, and the answer or the product is still going to be the same. But don't forget that the associative properties only work with addition and multiplication. Again, they don't work with subtraction or division. All right, and there you go. So let's go ahead and have some fun. Again, just remember, properties is just math rules that you just follow. Okay. All right, so we're going to introduce you guys how to identify equivalent expressions. So I do have 6 different expressions here, and what we're going to do is make some tables. Okay, so let's say that x equals 1, if x equals 2, if x equals 3, and x equals 4. Okay, we're going to substitute 1 for x here. So 4 plus 1 plus 4 is going to be 9. If we substitute, if x equals 2, we're going to substitute 2 for x. So 4 plus 2 plus 4 again is going to be 10. And we're going to substitute again, if x equals 3, then 4 plus 3 plus 4 is going to be 11. And if x equals 4, 4 plus 4 plus 4 is going to be 12. Okay, so if x equals 1, if x equals 2, if x equals 3, if x equals 4. Okay, so all we're doing right now is just trying to identify equivalent expressions. So same thing here. We have 16x. Again, your coefficient 16 and your variable x. If x equals, let's say 1 again, if x equals 2, if x equals 3, and if x equals 4. Tongue twister there. So 16 times 1, if we substitute 1 for x, 16 times 1 is going to be 16. If x equals 2, then we substitute 2 for x here, and 16 times 2 is going to be 32. Same thing. If x equals 3, we substitute 3 for x, and 16 times 3 would be 48. Same thing. If x equals 4, 16 times 4 would be 64. Okay. And again, we're making tables here, and we're going to see which ones matches with what. Okay, so again, if x equals, make these wider. So if x equals 1, if x equals 2, if x equals 3, if x equals 4. So we're going to insert or substitute 1 for x here. So we do 4 times 1 times 4. That will be 16. If x equals 2, we substitute 2 for x. So 2 times 4 is going to be 8 times 4 is going to be 32. If x equals 3, we substitute 3 for x, and 3 times 4 is 12 times 4 would be 48. And then lastly, substitute 4 for x, and 4 times 4 is going to be 16 times 4 is going to be 64. Now, do you notice something? So these two kind of match, these kind of match, these kind of match, and these kind of match. So 4 over 64, 4 over 64, 3 over 48, 3 over 48, 2 over 32, 2 over 32, 1 over 16, and 1 over 16. So we can say that 16x is equivalent to 4 times x times 4. So these are equivalent expressions right here. Okay, so these are equivalent expressions. Let's keep going. Okay, so for this one here, you can already tell that these two are equivalent expressions. So x here, if x equals 1, 2, 3, and 4. So 4 plus 4 is 8 plus 1 is 9. 4 plus 4 is 8 plus 2 is 10. 8 plus 3 is going to be 11. 8 plus 4 is 12. So again, these guys match. So again, you can even tell they're just kind of worded differently here with our math sentence. There's an x, there's a plus sign, there's a 4, and there's a plus sign and another 4. So these two are definitely equivalent expressions. Down below we have x plus 8. So again, if x equals 1, if x equals 2, if x equals 3, if x equals 4. Substitute 1 for x. Okay, so 1 plus 8 is 9. If x equals 2, 2 plus 8 is 10. If x equals 3, 3 plus 8 is going to be 11. If x equals 4, 4 plus 8 is going to be 12. Again, these two are equivalent expressions. Okay, pretty interesting, right? Okay, so you see 1 over 9, 1 over 9, 2 over 10, 2 over 10, 3 over 11, 3 over 11, 4 over 12, 4 over 12. Okay, down here, same thing. If x equals 1, if x equals 2, if x equals 3, if x equals 4. So substitute x. If x equals 1, we insert 1 here or substitute. 4 times 1 is 4 times 4 is going to be 16. So already you can tell that these guys again will be equivalent. Okay, if x equals 2, 4 times 2 is 8, and 8 times 4 is going to be 32. Okay, if x equals 3, 4 times 3 is 4, 8, 12, times 4 is going to be 48. And if x equals 4, 4 times 4 is 16, times 4 would be 64. So again, this would also be equivalent to 4, oops, well, I guess that's fine, x times 4. Okay, so there you go. So we found some equivalent expressions and just identifying equivalent expressions. So you get the gist, I hope, and let's move on. All right, so the first example that we have, we're gonna use properties to write equivalent expressions. Now we're gonna simplify the expression 7 plus 12 plus x. So what we could do is use the associative property of addition. So you see this parentheses here. You have a variable x in this algebraic expression. All we're going to do is rewrite 7 plus 12 plus x. And we're going to move the parentheses from 12 plus x to 7 plus 12. And 7 plus 12 is going to equal 19 plus x. And there you go. You just simplified the expression. That's all we do. Can't really do anything with x because x is your variable. We don't know the value of that variable, but you know, we're just simplifying the expression. It did not tell us to evaluate. Okay, so remember that. Next, we're going to simplify the expression 6 1/10 plus x plus 8 4/10. Again, same thing. You're going to use the commutative property of addition. What that means is it doesn't matter what you add first, your answer is still going to be the same. So with that being said, we're going to add 6 1/10 plus 8 4/10 plus x. Okay. Now, 1/10 plus 4/10 is 5/10. 6 plus 8 is going to be 14 plus x. There you go. Then on the bottom, simplifying the expression 5 times 11y. Again, we're going to use the associative property of multiplication, meaning that it doesn't matter which one we will multiply first, we're still going to get the same product. So we have 5 here times 11y. So 5 times 11 is 55y. There you go. Again, we just simplified the expressions, and we don't evaluate because it didn't tell us to. Okay. All right, so here we're going to still use the same concept what we learned before, using properties to write equivalent expressions. So we have on the left 9 times 0 times p. So we're going to simplify this expression. So let's use the associative property of multiplication. That means that it doesn't matter which one we multiply, we're still going to get the same product. So 9 times 0 times p. We do know that there's a 9 and 0, so we'll just do 9 times 0 and then times p. So 9 times 0, anything times 0 is going to be 0. Then 0 times p, again, is just going to be 0. So there you go. Easy peasy lemon squeezy, right? And now we have the other expression. Simplify the expression 4.5 times r times 1. Let's use the associative property of multiplication again. So all we're going to do is we do know that there's a 4.5 and there's a 1. Let's use the associative property though. So 4.5 times r times 1, and then we're going to use the multiplication property of 1 here. Anything times 1 is itself. So this is now going to be, so r times 1 is just going to be r. And bring 4.5 down. 4.5 times r is just going to be 4.5 r. There you go. So you have the variable r and the coefficient 4.5. Okay, that's all we do. All right, with this last one, we're going to model real life. So we're going to pay attention to the wording in this statement here. So let's pay attention. So you and your friends, we're going to read them. You and your friends play on a basketball team. So there's a sponsor, maybe Subway sponsors you guys. And Subway paid $100 for the league fee. They paid an X amount of dollars for each player's t-shirts, and $68.25 for basketballs. So we're going to write, the first thing we're going to do using this information is to write an expression that represents the total amount in dollars that the sponsor paid. Then the second thing is that we're going to find the total amount paid when each t-shirt cost $14.50. Okay. So one thing, things that we do know is that the league fee in dollars, the league fee is $100. That's what we do know for sure. We're going to add that to the number of t-shirts. So number of t-shirts. Okay. So the number of t-shirts we had to buy for that basketball team is everybody on that team, we had to buy them a t-shirt. So this is not going to be 6 players on the team. No. You had to really listen. So you and 6 friends. So that means there's 7 people. 7 people need t-shirts. And then let's see, we're going to have to multiply that times however much it costs per t-shirt. So the cost per t-shirt, we'll just put an X value for that for now. And then we're going to add that to the cost of basketballs. So the total cost of basketballs in dollars is $68.25. So using this information that we pulled from the statement there, we're going to go ahead and make an algebraic expression. So we're going to have 100 plus 7 people. We don't know how many t-shirts it's going to cost, or how much it's going to cost us for the t-shirt, so we just put X there. Plus the basketballs, $68.25. Let's see here, things that we do know. Let's see here, this would be like maybe 7x plus 100 plus $68.25. So 100 plus $68.25 would be $168.25. Okay, bring the 7x down. So there you go. This is the simplified expression. It says write an expression that represents the total amount in dollars that the sponsor paid. Right here, this is how much the sponsor paid. And then it wants us to ask us to find the total amount that the sponsor paid. So X here equals $14.50. So if X equals $14.50, we're going to have to substitute $14.50 for X. So this is now going to be 7 times $14.50 plus $168.25 for everything else. And then do some math. Let's see here. 1450 times 7, 0, 35, 7, 14, 21, 28, 29, 30, 31, 7, 8, 9, 10, 1, 2, boom. So there you go. So this is going to be $101.50 plus $168.25. Altogether, it's going to be $269.75 that the sponsor paid. There you go. It's easy peasy lemon squeezy. Again, all you're gonna have to do is pull information from the statement and then make a expression and then solve it. So just pay attention to what you read. Okay. All right, that concludes our 5.3 properties of addition and multiplication. By now, you should be able to explain the meaning. What does it mean by equivalent expressions? You should also be able to now use properties of addition to generate equivalent expressions, and use properties of multiplication to generate equivalent expressions. By that, I mean using the commutative property of addition, the commutative property of multiplication, the associative property of addition, and the associative property of multiplication. Again, just remember that these only work for addition and multiplication. They do not work for subtraction or division. All right, so we need to get some more practice in. I know this is probably it looks like it's difficult, but it's not. It's really fun. So all we're doing is like looking for a missing value and just paying attention to the wording and to make words into number sentences.